So in this video I will show how to resolve the solution of a equation to a matrix resolution by Gauss-Jordan, and we will also know how to resolve these two index, that is final values of C if any, for which given matrix is A inverse. So to start this, we have to translate this equation into a matrix. So that will be 1, 3, minus 2, 2, 0 because we don't have a x4, 2, 0, we don't have an x6, and 0. 2, 6, minus 5, minus 2, 4, minus 3, minus 1, 0, 0, 5, 10, 15, here we have a 0, 0, 15, 5. So here 2, 6, 8, 0, 8, 4, 18, 16. You have to be really observing our equation, because you can have like x3 putting a d8 when you have to put 0, so we have to look into it. So once we have our matrix, we have to do our Gauss-Jordan rectangle formula as we know it. So our first formula, we have to eliminate the zeros below 1. So in this case, we will just multiply row 2 times row 1 minus 2, as well as row 4 times row 1 minus 2. So doing this calculation, our matrix will result to be so once we have this, now we have to multiply row 4 times row 2 times 4. So we will just eliminate our zeros times 4. So as well, we have to do this with 5. Is row 3 times row 1 times 5. So leading that result, it will leave our matrix Our next step is changing this row into this one, exchanging those, because we need to have the zeros below everything. So in this case, we just change 6 and 2 here up here, and 0, 0. So we divide this by 6, these rows, and this by minus 1. So we can have our full ones here. So our final matrix will be we have to put this into equation. So in this case, our equation will be x1 plus 3x2 plus 4x4 plus 2xy equals 0, x3 plus 2x4 equals 0, and x6 equals 1/3. We have to put this into lower equations just by substituting I will skip that step to be more effective in this case, because we have to put this, we have to do a substitution. So the substitution will lead us here, this x3 into x3 minus 2x4 x6. Once we have our solution, we have to identify our free variables. So our free variables will be x1, no, x2, x4, and x5. We can just say that x2 is r, x4 s, and x5 t. So this is our solution for this x, and for this x we just substitute this. So we have that x6 is 1/3, x3 is 2s, and x1 we just send all that way, so it will be minus 2r plus 4s here minus and minus 2t. So that's our result for this video. So now we have to jump into these problems. So the first thing we have to do, we have to know which numbers are invertible into this matrix. So the first thing we have to do in this case is change our rows. In this case we will be 1, 1, 1c, 1c, c. We have to multiply our rows by minus row 1 times row 3 and c row 1 times row 2. This is gonna be mass plus and this minus. So by doing this, we can say we have 1, 1, c, 0. So by having this, we can we don't go on with the problem, because we know that we cannot do this with c equals to 1 and c equals to 0. By substituting in these formulas, it will not lead us to 0. So that's why it have to be a number that is not 1 or 0 in this case. So we keep going to B, our final problem. So it's almost the same as the first one, kind of different, but we want to start changing our rows. So we change row 1 by row 2, and then row 2 by row 3. So it will be something like this. 1, 0. It will turn out like this. So now we have to multiply minus c by row 1 plus row 3, and we have to, after we do this multiplication, addition, we have to now multiply our row 2 times c squared minus 1 plus row 3. By doing this operation, we have that our matrix is 1, c, 1, 0, 1, c, 0, 0, c, cube, minus 2c. So just by substituting 0 into this little equation, we have that this is equal to 0. So we have that c is equal to 0. So this is not a number. So the next step we have to do is by this formula. we know that in our C it can also not be 2. The square 2 plus or negative. So these are our non-invertible values for our matrix. So is all for the video today.